Welcome back. This is the third section of the Shaders and Effects in Unity 2019 course. In this section, we will take a look at the shaders. There is only one topic I would like to cover before we move on to the shader lab and shader graph, textures. In this video, we will talk about the texture types and Unity's texture importer. This is a relatively simple topic, and the importer hasn't been changed in Unity 2019. If you are an experienced Unity user and know the settings in the importer, then feel free to skip this video. Otherwise, let's select a random texture from the assets and check out the texture importer. The first setting, and probably the most important one, is the texture type. Select Default, which is the first option. Default textures are used for the general 3D stuff. This option provides most of the properties for texture importing. The texture shape setting has two options, 2D and Cube. While the 2D textures are just regular general purpose textures, Cube textures define texture as a cube map. Cube maps can be used for skyboxes or reflection probes. There are three mapping settings for the cube textures: mapping, convolution type, and fix up edge seams. The mapping specifies how the texture is projected to a game object. With the auto selected, Unity tries to work out the layout from the texture information automatically. 6 frames layout is the standard for the skyboxes. Think of a cube with inverted normals and painted surfaces. Imagine unwrapping it and you will get the idea. Similarly, latitude-longitude maps the texture to a cylinder instead of a cube. Mirrored ball does the same thing but with a sphere. Convolution type can be disabled or set either to specular for glossy reflections or to diffuse for irradiance. The Fix Up Edge Seams option is a workaround for low-end platforms for filtering limitations. Set the sRGB option to true if the content is stored in the GAM space or if the texture is not an HDR texture. Ideally, the dimensions of all important textures should be a power of 2, such as 32, 64, 128, etc. It is possible to use a non-power of 2 textures. However, they usually take slightly more memory and might be slower for GPU to sample. Unity can scale up the non-power of 2 textures up to the nearest power of 2. This is what the non-power of 2 settings is all about. It tells Unity how to scale textures, dimensions of which are not the power of 2. To nearest option will scale the non-power of 2 dimensions to the nearest power of 2 dimensions. To larger option will always scale the texture up, while to smaller will always scale the texture down. Enable the read-write setting if you wish to access and change the texture from the code. Enabling it will create another copy of the texture, doubling the size of the used memory. Enable this option only when it is absolutely necessary. Texture streaming reduces the total amount of memory Unity needs for textures by only loading the MIP maps it needs to render the current camera position in a scene. This option might save a lot of GPU memory by trading it for a small amount of CPU power. It does not make sense to render the texture at a full resolution if the object is far away from the camera. To avoid it, Unity and other 3D game engines generate small versions of the texture and use them as the object gets further away from the camera. This is what a MIP map is, a list of progressively smaller versions of an image. It uses 33% more memory, but it dramatically improves the overall performance. Border MIP map option is used to avoid color bleeding out of the edge of the lower MIP levels. It is used for light cookies. There are 2 options for the MIP map filtering, box and Kaiser. The box is good enough for the most of the time, but if the textures are too blurry in the distance, try Kaiser. Enable MIP map preserve coverage setting if you want the alpha channel of generated MIP maps to preserve coverage during the alpha test. It means a higher percentage of pixels passes the alpha test and lower MIP map levels do not become more transparent. Enabling the fade out MIP maps setting will make the MIP maps fade to gray as the MIP levels progress. The leftmost scroll is the first MIP level to begin fading out. The rightmost scroll defines the MIP level where the textures is completely grayed out. Wrap mode is how the texture behaves when tiled. Repeat will repeat the texture in tiles. Clamp will stretch the texture's edges. Mirror mirrors the textures at every integer boundary to create a repeating pattern. Mirror once mirrors the texture once, then clamps it to the edge pixels, and per axis allows you to individually control how Unity wraps textures on U and V axis. Filter mode defines how the texture is filtered when it gets stretched by 3D transformations. No filter means that no smoothing will be applied and you will be able to see each pixel when you get close to the texture. Use this option for pixel art games. Bilinear blurs the textures. Trilinear is similar to bilinear, but the texture also blurs between the different MIP levels. Anisotropic filtering increases texture quality when viewed from a low angle. This is a resource-intensive process and is recommended to use only for ground or wall textures. These are the settings you need to be aware of when importing the textures and using them in shaders. We didn't check the other texture types, but the settings are mostly the same for all of them.